Good morning. Today we're going to start talking about the chemistry of life. Atoms are the basics of everything that we know in this universe. An atom is the smallest particle of an element that has all the characteristics of that element. Now, all atoms have the same basic structure. They're all built the same way. Right, the center of the atom is called the nucleus, and it is made up of positively charged protons. They are abbreviated P positive, and neutral neutrons, N with a little O up there to show their neutrality. Right, so all nuclei, which is the center of the atom, have a positive charge because they have a plus and a neutral. Now, negative particles called electrons, E with a little negative sign over there, orbit the nucleus. Atoms contain equal numbers of electrons and protons, so they have no charge. All right, so when you look at an atom, what you're seeing is your nucleus here, and there are your protons and your neutrons, and then around it, all out here, there's your electrons. This is called the electron shells or the electron cloud. They literally orbit the nucleus there. All right, and so there are about 90 naturally occurring elements, and of those, only 25 of them, just 25, are essential to life. So just 25 of them are essential to life. Now, 4 of those elements, just 4. Carbon, which is C, hydrogen, H, oxygen, O, and nitrogen, N, make up more than 96% of the human body. So right here, your human body is carbon, hydrogen, oxygen, and nitrogen mostly. And then there's one more element, phosphorus is added after that, which is the last essential element to make up the organic molecules. Now, organic molecules, y'all, are the molecules that build living things. That's what we mean by organic molecules. All right, water is essential to life. You can't have water. You can't have life without water. Now, it is probably the most important compound in living organisms. Okay, this is key here. 70 to 90% of most organisms is made up of water. So even though you look really solid, you are actually mostly water. Now, most life processes can only occur when molecules and ions can move around and bump into each other. So think about the blood that flows through your body. Well, blood is essential for life, and it carries all the nutrients, all the vitamins, all the minerals that you need to stay alive. Well, your blood, because it's liquid, is mostly water. So those vitamins, those minerals, those nutrients, they can only move around when they're dissolved in water. So we know water as the universal solvent. Okay, water is the universal solvent because it will break down just about anything if you give it enough time. Now, the way that water is formed makes it a polar molecule. Y'all, this word is very important, polar molecule. Okay, that's what water is that makes it able to do so much. And by polar molecule, we mean that it has 2 ends. Okay, so here's your 2 ends. Here's one. Here's the other one. And those 2 ends each have a slight charge. One end is negative. That's your oxygens up here. And one end is positive. That's the hydrogens down here. Okay, they are slightly charged because the oxygens like to steal the electrons. Okay, and so when they the oxygen steals the electrons from hydrogen. That makes them positive because this took away the negative, and it makes this one negative because it took more negative. Right? So that makes it a polar molecule, though. And that makes it like a magnet. So it can easily attract other molecules and cling to things, especially other water molecules. So water molecules sticking to other water molecules. That's called cohesion. So when water sticks to itself, that is cohesion. Now, because of this attraction to everything, water can dissolve particles that organisms must have to live, such as salt and sugar. All right. So water is able to, here's your water molecule right here. And so it can like wiggle its way in between these. It can totally wiggle all in here. This one can do the same thing over here. And it can break them apart like these. Okay. And so it separates them by breaking them apart. And once it breaks them apart, these little tiny molecules that are down here, all right, these little molecules, now they can get moved all around your body. All right, also because of its polarity, water can cling to walls, so adhesion. Now, y'all, what that means by adhesion is water can cling to other things. So cohesion is water to water. Adhesion is water to other things. All right, so it can climb walls, and it makes it important in plants because when it can climb up in plants, that's called capillary action. And that's its ability to climb up in tubes. And it could be your drinking straw or the little tubes that are inside plants. But either way, it lets water get to the tops of plants. That's how plants can stay alive, is by capillary action. All right, and so here is an example of capillary action. This would be like this says glass tube, but think of it like your drinking straw. When you put it in something, you've seen the water kind of go up it and pop up. Well, water can climb up plants the same way. All right, so it works great to let water get everywhere it needs to go. All right, that's it for today.